that same formula that we were using to determine our confidence intervals last week. We still will be using your Z-chart, so you might want to get out your Z-table. If you don't have your confidence intervals or your confidence levels and your Z's memorized, which I don't expect you to, you probably will want to have that out. But the margin of error is that Z value times the standard deviation. That's how much you are adding and subtracting from the mean to determine your interval range. And that number that we're adding and subtracting is called the margin of error. And so today we are actually going to solve to determine the sample size. So we want, if I tell you that the margin of error is 5%, you want that margin of error to be less than or equal to 5%. So we are going to solve today. That's why I kind of circled, drew attention to that Z times the standard deviation is less than or equal to the margin of error. So we want those values to be less than whatever our margin of error percentage is. And then we're just going to do some algebra today and solve for n. All right, so everybody has their calculators. Now, on that first example, it says, what is the smallest sample size needed? Because sometimes sample sizes are too small. We want to know what's the smallest sample size needed to keep a 90% confidence interval within 4%. So we don't want our margin of error to be more than 4%. If we do this, we have to know the z-score from the table, and then we have to know the probability of success and failures, and once we do that, we can solve for n. So we're talking about a 90% confidence interval. So the first thing I want to do is find the z-value for that. So if it's 90% confidence, what are we going to look up on the chart? All right, so if the middle chunk is 90, how much is each tail worth if it all adds up to 100? All right, so on your chart, you're going to look up 0.95 because the chart includes our left tail. So if we look up 0.95, I don't think we have an exact, it's in between, right? All right, what's it in between? Okay, so what z values is that in between? 1.61. All right, so if it's in between those two, 1.645. Now, are we given a probability of success or failure here? Do you see anything? All right, so if we don't know a certain probability of success, if you have two options, if it's not given to you, we just assume it's 50 and 50. That's the worst thing that it could be. So if it is not given to you, we just assume that it's 50-50. We just split it right down the middle if it's unknown. Now, if it's given to you, you use what's given. But if you aren't given a probability of success, Jacob, write that down. If you aren't given a probability of success, we assume it's 50-50. And now we are going to solve for n. So we want that margin of error, all of this, we want it to be less than or equal to our margin of error, which in this case is 4%. So we want it to be smaller than 0.04. If it's bigger than 0.04, then we're beyond the range that we want. So we got to be right at 4% or smaller than 4%. So let's plug in what we know. All right, we know Z is 1.645. We know P and Q are both 0.5. We don't know our sample size. That's what we're trying to find. And we want it to be here. All right, so now we've got to do some algebra. All right, so our ultimate goal is to get n by itself. So we've got to get rid of everything on that left-hand side besides the n. All right, does that 1.645 have anything to do with the square root? All right, but we're multiplying it to the square root, right? So how do we get rid of times 1.645? All right, so that's the first step. Always divide the z-score over. So now, let's simplify the numerator. What would be the square root of 0.5 times 0.5? And so you guys can just type that right in. It's 0.5, because isn't 0.5 times 0.5 squared? Take the square root, which is be point. So this right here simplifies to 0.5. Now, the square root of n can't be simplified. So we just leave it the square root of n. Because if it's all in one fraction, it means take the square root of the top and the bottom. No, not. All right. For the next part, so we've divided our z. And I just went ahead and simplified my numerator on the left-hand side. We want n to be by itself. We need it in the numerator. So it is totally okay to flip a fraction. If we want n in the numerator, we can flip the first fraction, but what do you think you have to do the second fraction? All right, so if you're flipping the fraction, can we leave the inequality as it is, or do you think we need to flip it too? Yeah, you're going to flip everything. So whenever we want to flip this, it is totally okay to flip that as long as we flip the second fraction. Oh, I need more room. Okay, I'm actually going to write it up here. So the square root of n divided by 0.5. I'm going to flip my inequality. All right, so now we just got to simplify a little bit. All right, do we like that divide by 0.5 that's with it? All right, how do we move a divide by 0.5? All right, so multiply that 0.5 over. So I'm going to multiply this by 0.5, multiply that by 0.5. So now I think I'm ready to type some stuff into the calculator. So we are going to take 1.645 divided by 0.04 and then multiply it by the 0.5 that we multiplied over. So we simplified the square root, we flipped the fractions to get the n in the numerator, so it's a little bit easier to solve. And then we multiplied that denominator of 0.5 over to the other side. So I just typed in 1.645 divided by 0.04, and I got 41.125, then took my answer times 0.5. If you do it all in one step, that's okay too. I got 20.5625. Do you guys agree with that? All right. So it says the square root of the sample size has to be bigger than this. And then how do you get rid of the square root? Square both sides. So now square that number. So just square your answer. And you get 422.816 and some stuff. So we want a sample size bigger than 422.8. So greater than needs to go up. So what's our smallest sample size? You say round it to the nearest whole number. What are we going to? Yeah, 423 or larger, but 423 is the smallest sample size. If we had a sample size smaller than 423, it would make our margin of error too big. So we're just doing some algebra. And I promise the more times you practice this, probably the less work you'll need to show. So we divide the z over, simplify the square root in the numerator, then flip the fractions, and then get in by itself by squaring both sides. I'm going to say, do you guys have any questions on that solving part? I'm going to say, are you guys awake? I'm gonna say, if you guys think this week's rough, next week we're changing time, and it's gonna go back to being dark in the morning.
No, it's not.
Yeah, we changed times on Sunday.
That's not funny.
Sorry, I'm just the messenger.
We lose an hour of sleep too, don't we?
Yes, because we spring ahead.
I say senior skip week. Let's go.
No.
Senior skip week. I'm not gonna be here the week after spring break, by the way.
I think you told me.
Yeah, I don't know if I told you or not. I don't know what teachers I've told and which teachers.
You know, say I'm recording.
Oh.
Like, well, no, that's like
I thought
I
you
mean,
meant
like
right now.
I will, like whatever we're doing, I will record it.
I'll
So,
have internet and I'll do stuff.
okay, sounds good.
When do you flip the sign?
Okay, when you flip the fraction, that's when you flip the sign. All right, so we'll do another one. Okay, let's take a look at this one. Change.
Like if I'm playing something, she'll just make random noises. Like she won't play with the same words, she'll just get like nervous.
I'm gonna say, Annie and Mindy, I'm really sorry. I'm not trying to make you sick. I'm gonna say, trying to zoom in wasn't good. Okay, let's take a look at this next example. This time I actually give you a value for probability of success. What is that? All right, probability of success is 0.8. So that means probability of failure is? All right, now hopefully you have this one memorized. What's the z that corresponds with the 95% confidence interval? 1.96. Yeah, that's the 1.96. And then this right here is our margin of error. We want to be within 1%. So we want to be pretty accurate here. So we just plug in what we know. We want the z value times the standard deviation to be less than or equal to our margin of error. So let's plug in what we know. What do we know for z? 1.96, and then our square root. This time, our numerator is 0.8 times 0.2. We don't know our sample size, but what do we want it to be within? 0.01, 1%. All right, what's my first step? Divide the z. Jacob, are you with me?
Yeah.
All right, so we divided by the z. Now, can we go ahead and simplify the numerator here? Take the square root of that. All right, so 0.8 times 0.2 is 0.16. What would the square root of that be? 0.4. So all of this here, when you take the square root, ends up being 0.4, and then the square root of n hasn't been solved yet. And then we have 0.01 divided by 1.96. now that we've simplified, are we ready to flip? Okay, everything gets flipped. So how am I going to rewrite this? All right, and then are you okay with me multiplying this 0.4 over? Just multiply by 0.4. All right, let's plug that in. All right. All right, I need a number. So we're dividing 1.96 divided by 0.01, multiplying it by 0.4.
78.4.
All right, so the square root of n is going to be greater than 78.4. All right, now, how do I get rid of that square root? So then we square both sides. So let's square that. And that will tell us our sample size. What does that have to be greater than? 6,000 what? Are you guys getting this on your calculator? All right, now can we have a 0.56 of a sample size? Round up. So on this one, we round up 6,147. That would be the smallest. Now, would it be okay to have a sample size of 7,000? Is it okay to be bigger than that number? But is it okay to be 6,145? No. I'm going to say not quite. All right. I actually want you guys to try this next one by yourself. So you will have to find the Z for an 86% confidence interval. Since it's not given, we assume it's 50-50. Very good. All right, so 86 is in the middle. How much is each tail worth to make 100? Thanks, Jacob. All right, so you're not looking up 86 on the chart. Was anyone else just as excited about the Disney Tournament of Characters as I was? I haven't even made my bracket yet.
I made mine. Is that only for Spanish kids or is it?
No, it's for everybody.
Oh, I didn't do it.
I'm not Spanish anymore.
No, it's for everybody.
Usually people vote so many times themselves and just vote for all the upsets, so it doesn't even make it fun.
I only voted.
Like Michael Scott lost like first round.
I
his
was
sophomore year.
really upset about that.
Yeah. I don't remember any of the other ones, but Michael Scott should have won the whole thing, and someone voted
Yep.
himself.
And was it last year that Ravi made it to the Final Four? And that one kind of shocked me.
Yeah. Robbie sucks.
Like, out of all of the characters on those shows, Ravi is definitely my least favorite. I really like Zuri. Zuri is my favorite out of all of those.
Bertram.
Hmm?
Bertram's the best one. Bertram probably didn't even make it to like the Sweet 16 even.
I don't know.
It's rigged.
No, I need to make I have to do a paper bracket before I fill it out electronically, or I never know what I'm really picking. All right, so let's see, 0.93.
Wait, we can do it multiple times.
Hmm?
We can do it multiple times, like every time.
No. You can vote. Like whenever it's time to vote, you can, once you submit your Google form, you can keep hitting refresh, and it'll, every time you hit refresh, your vote will count again. All right, so you guys looked up 0.93 on the chart, right? What'd you guys use for a Z-score? I'm gonna say 1.475 is correct. So we assume it's 50-50, so we're using 1.475. Hey, is it okay to automatically start like that? Is it okay just to divide my z over? Like, we know that's going to be our first step. If you guys want to write it like that, I'm okay with that. Now, if you need to put the z in front of the square root and show your work that you're dividing, I know some people really like to have really nice and neat work. But if you guys want to go ahead and put that z over in the denominator, I'm okay with that. Now, for the next part, we got to simplify that numerator on the left. What would the square root of all of that be? All right, that's 0.5 divided by the square root of n. All right, are we ready to flip? All right, next question. We don't really do a lot from this step to this step, right? Do you think I'm okay with you going from here and automatically flipping it and simplifying at the same time? If you want to do that, you can. If you want to, you say, I know this is 0.5 and I know I'm going to flip next. If you want to immediately go there, that's okay. So then, I'm going to multiply my 0.5 over here. So what do you get when you plug all of that in? Do you guys agree with Audrey there?
Yes.
Now, did you square it already?
I did by myself, yeah. I got 605. That's
Yeah.
what I rounded up.
Yeah, so then once you square it, we want it to be greater than or equal to 605. Now, do you guys think you could do some on your own? You know, say it's not, I don't think it's terrible, but I am okay with you guys skipping some steps there. Now, I do have one more question type that I have over on that right-hand side of the board. And this isn't, I don't want you to think this isn't super complicated. So on this one, it says, what happens to a margin of error with a sample size of 50 versus a sample size of 200? All right, so if I do the margin of error, same information, just a different sample size. Does the z number really have anything to do with it? No. The only thing, you just want to compare the two sample sizes. Compare the standard deviation of each one. Because the only thing that's going to be different is that, right? Now, I'm not giving you a probability of success, so let's just assume it's 50-50. Let's compare these. All right, so let's type in the standard deviation with a sample size of 50. So 0.5 times 0.5 divided by 50. What does this become? 0.0707 and some stuff. Now, don't clear your memory, because we're going to come back to this in just a second. All right, now let's do that for this one. Square root of 0.5 times 0.5 divided by 200. What do we get for that? .0353 and some more stuff. Just by looking at this, we all know this one's bigger, right? By how much? You're gonna say, let's look at the numbers. 070, so think 70. 035, it's double. So this one is double. So I want you to fill in the blank. The margin of error of the smaller sample size is something, the margin of error of the larger sample size. How would you fill that in? So we said double. So would we say that's half or 2 times the smaller one? Yeah, it's 2 times the smaller one. And if you ever want to know the relationship there, it's asking you to compare the larger one to the smaller one. Do you guys know how to copy and paste on these? All right, so do you guys have your word with these decimals still there? I want you to go up with your arrows and highlight the .707106. Highlight that. Go up to your arrows until you highlight that answer and hit enter, and it'll paste it right into your line. And then divide it by the other one. So then you're going to hit divide by, then go up and highlight your second answer, and then hit enter. So like, do you remember in middle school doing ratios, and it would say like, what's the comparison of the larger one to the smaller one? And 2 meant divide. So you're going to take the smaller sample size divided by the larger sample size, and it's almost 2, right? Yes. Because maybe on your assignment today it's fill in the blank and it'll say 2 times or 1/2.
Oh.
And I want you to pick.
Okay.
So if I had switched these words, if I put the larger one first, if I took the larger one and divided by the smaller one, it would end up being really close to 0.5, and then you would say half. So you just have to read the questions on those. You're just doing ratios, but you guys have the rest of the time today. In this next 10 minutes, I'm going to enter your scores from last week. And then you guys have 2 Khan Academies that are due tonight, the ones from Thursday and Friday. The sample size one that from today is not due until Wednesday.
Oh, wait, what? Never
So
mind.
your
Remember Khan Academy that
Your
today?
con, yes. So you have 2 that's due tonight.
Yeah, I
The
see it.
finding the Z, so learning or just going like from the table to the confidence, from the confidence to the table, one or the other. That one is due tonight, and also calculating the confidence interval where you do the plus and minus.
And then do you know who has the ones for today done?
Well, as of the last printout I have, you're good, but one of them could be improved.